What we mean by acceleration. We also have to discuss what does it mean to have a negative acceleration, a positive acceleration. And one problem is, especially in everyday life, when we talk about something is accelerating, we usually mean that its speed is increasing. Now in these examples, you see, in the first one, the speed is increasing. So the speed changes from 3 meters per second to 5 meters per second. The velocity is also changing, but the velocity changes from -3 meters per second to -5 meters per second. So this just tells me that the object is accelerating in the negative direction. The acceleration is -1 meters per second. So we have, let's say, this line, the object is moving along this line. This is our negative axis. So the object is accelerating in this -1 meters per second. Now, if my object, let's look at the third case. Let's see, if the initial velocity was 5 meters per second, the final velocity was 3 meters per second. The object is slowing down. Nevertheless, it has an acceleration, and its acceleration, now in the first case, the object is speeding up. The speed is increasing. In the third case, the object is slowing down. The speed is getting smaller and smaller. But in both cases, the acceleration is still the same. Average acceleration is -1 meters per second squared. Now, the main confusion is from the definitions. The acceleration is always defined in terms of the velocities. In one dimension, the velocity can be both positive and negative. Even if an object is slowing down or speeding up, depending on what was the direction of the initial velocity, they can still have the same acceleration. Here is an example where the object is speeding up. In this one, this is an example where the object is slowing down. But in both cases, they have exactly the same acceleration. Of course, in everyday life, when we say accelerating, we mean it's speeding up. When it is decelerating, we mean it's slowing down. But that's not how we define it in physics. Okay, any questions on this one? Any more questions on this one? Is it clear now, or do you want some more explanation? You see, I can guarantee you that still at least half of the classroom is confused. But if you want me to continue discussing, at least one of you should ask some questions. Okay, what did we say? Yes. That is mainly because -5 is smaller than -3 as a number. Now, the thing is, here we are in one dimension. We haven't yet discussed the vectors. When we go to 3 dimensions, we will not be able to do such a comparison. But in 1 dimension, we can still treat these as if they are ordinary numbers. So that's what I mean by, what do you mean by a positive acceleration? It's an acceleration in the positive direction. Or a negative acceleration, it's an acceleration in the negative direction. Now, when I say that V final is smaller than V initial, what I mean is its numerical value or its component. Its magnitude, which is the speed, of course, V final is larger than V initial in terms of its magnitude. Now, when we discuss vectors, the distinction will be more clear. I mean, we can still do it in 1 dimension, but I agree with you, it's not such a good practice, let's say. Because when we will be discussing vectors, we cannot really compare vectors, one is larger or one is smaller. We can only compare their magnitudes, which will be their speed. Other questions?
The acceleration is decreasing and the speed is increasing. What do you mean?
Okay, so what's the meaning of the acceleration is negative or decreasing? Acceleration is negative, the speed is increasing. So that will be if the acceleration of an object is in the minus direction, and if the speed is increasing, that will tell me that the initial velocity is also in the minus direction. So I have my object in that direction, it's accelerating in that direction, it's initially moving in that direction, it's speeding up in that direction, so the acceleration will also be in that direction. Now if my object is initially moving in that direction, but the acceleration is in the positive direction, but the acceleration is in the negative direction, it would mean that at the next instant, the velocity will be closer to zero, so it will be slowing down. But if the acceleration and velocity, they are both in the same direction, when I add them up, the next instant, the velocity will have a larger magnitude, so it's speeding up. Questions? Any questions on speed, velocity, acceleration? Now, in these examples, we don't know how the acceleration is changing. We only have the velocity is at 2 times. That's the only thing we know. So we don't know whether the acceleration is changing or not.
Is there a term for difference in speed per unit time?
Well, difference in speed per unit time, not really. Well, in the case of the instantaneous velocities and instantaneous accelerations, yes, I think so. But not for the averages. Other questions?
Although you just said that instantaneous acceleration could be positive with this rate.
Instantaneous acceleration can be?
You said that acceleration could be positive if we're talking about the instantaneous acceleration. Even when we're going to negative direction. Like, I'm accelerating to negative direction. Is my instant acceleration positive or negative? Isn't it negative?
Yes.
You just said, I just thought you said it.
No. Okay, so we had the first meeting last week. There was something we planned with one of my ex-students from last year. So she was volunteered to give you some suggestions from the perspective of a student. So she's now here, and well, would you be interested in listening to her? So what it will be waiting for you this semester, and some of her suggestions as a student that passed through all the things that you will be passing through this year. So Zainab, she was also the head of the physics club, right, last year? No, you were involved. Okay. Okay, so I will just give the microphone to her, and well, I will be going out so that you can just ask whatever questions you like.
Can you hear me?
Okay, now we had a heavy schedule today. Okay, so back to physics. Any more questions on speed, velocity, acceleration, etc.? Okay, so let's look at an example. Now we had made the definition, let's try to use them. Now, one of the common phenomena that we see around us every day is motion with constant acceleration. Now, experimentally, for example, we know that if you just throw any object vertically up, okay, not this one, but a small object, if you just throw it vertically up, ideally in vacuum, but even if it's not in vacuum, if you have a heavy object or an object that's very small, it just accelerates with constant acceleration. And the value of that acceleration from measurement, we know that it is something around 9.8 meters per second squared. It's constant whether the object is heavy or light, the acceleration is always constant. Now, by the way, there are experiments going on who is trying to see some deviation from this 9.8 for different materials. So if one day we discover that two objects accelerate very slightly differently, then that would probably bring an alternative Nobel Prize. Now, we are looking for the so-called fifth force, but until now we don't have any evidence for it. Now, of course, this value just changes from location to location and changes depending on your height from the surface or your distance from the center of the Earth. We will study those variations in future chapters, but for the time being, let's just assume that the acceleration is constant, whatever the value is, and let's try to study the process. Now, since the acceleration is constant, okay, so we are looking at motion. Since we are only studying a one-dimensional motion, we will be assuming that we are just throwing an object vertically up or vertically down. First of all, we have to choose some reference point. What should be our reference point? Let's say I'm just throwing this object vertically up. So what should be the reference point? Ground. Okay, let's take the ground. So you would like to start with the initial point at 1 meter from the ground. Okay, what should be the positive direction? Up. Well, I will go down. Why not? I mean, I'm sure you have, in all your life, you have always chosen the up as your positive direction. Now let's choose the downward as the positive direction. And see if I can get you some even more confused. Now, the acceleration is this is the positive direction. So this is ground. This is, let's say, Z. What should we call this axis? Y. X, Z. Let me call the axis B. Why not? It's completely up to you. Whatever, I mean, of course, if you want to be readable by others, you would prefer to stick to the convention that the vertical axis is either Y or Z, but you don't have to. Let's call it, well, let's stick it with Z. What's the acceleration of my object? Plus G or minus G? Plus G minus, who says minus G?
First it's going up, or
Does it matter? Yes or no?
you define the direction.
So this is the question. If I throw it vertically upward or I know that the object will be always accelerating toward the ground. So if I throw the object vertically upward or vertically downward, would it make any difference what the acceleration is? Acceleration is always the same. It is always pointing in our plus direction. So the acceleration is always g. Not minus g, it is always g. So since the acceleration is constant, it is also equal to, since the acceleration is constant, we know that its average is also equal to our acceleration. We know the definition of the average acceleration. It is equal to, let's say, the velocity at time t, whatever that time was, minus v0 divided by t minus t0. This is the definition of the average acceleration between the time t0 and t, but since the acceleration is constant, we already know that the average acceleration over any time interval will be the same as this constant acceleration. So this is equal to, now let's just use g And if you just, well, I would like to simplify some of the expressions. So I will just choose t0 to be equal to 0. Now I'm free to choose my 0 times 0, whichever. I'm free to choose my reference point. I'm free to choose the 0 time of my measurements. So I'm just saying that at t0 time is the 0. So the velocity at time t will be nothing but v0 plus g of t. Now let us assume that I have this object, I'm just throwing it up. Of course, in one dimension, not 2 or 3 dimensions. What was the initial velocity? Let's say that initial speed was 5 meters per second. What is the velocity? Initial speed. Initial velocity S0 is 5 meters per second upwards. So we have to write the initial speed. Minus or plus? Okay, you see, according to my definition of the positive sense of the axis, upwards is the minus axis, is the minus direction. So since I have this speed, it's pointing upwards, the velocity is minus 5 meters per second. And hence we know that the velocity at the time t would be given by minus 5 meters per second plus 9.8 meters per second squared times t. This is the velocity as a function of time. So if you just tell me that you want to find the speed at, let's say, at time t is equal to 0.1 seconds, if you want to calculate this one, you just stick 0.1 seconds over here and obtain the value. It will be minus 5 meters per second plus 9.8 meters per second squared times 0.1 seconds, which is minus 5 meters per second plus 0.98 meters per second squared, which is approximately minus 4 meters per second.
It's wrong.
So is it going up or down at t equal to 0.1 seconds? Up. Because we have calculated the velocity at this time to be minus 4 meters per second, and this minus sign just tells me that it's still going in the minus direction, which is the upward direction. Did it slow down or speed up? It slowed down. Now, it will keep slowing down as long as it is going upward, because the velocity and acceleration, they are pointing in opposite directions. So it will be slowing down. And at time, let's say, t flight. No, not t flight. At time t1, the velocity will be 0. So what is t1? Now, we know the velocity as a function of time. We had calculated to be v0 plus g of t. And v of t1 will be just v0 plus g of t1, which should be equal to 0. So this tells me that t1 is equal to minus v0 over g. Is this a positive time or a negative time? Well, in general, we don't know. It can be positive or negative, because v0 can have any value. It can be positive or negative. So in this example, if we are throwing it up, in that case, we know that v0 would be negative. So v0 over g would be a negative number, and hence the negative of a negative number, this will be a positive number.
The time is always positive also. On the other hand, the time is always positive.
Yes, the time is always, well, not necessarily. Let's come to that point later on. Just don't forget your question. The time is always positive. It doesn't have to be. You see, we fixed the time t equal to 0, as the moment that I throw this up. But there are previous times also. Time can be negative. But I mean, we will do an example on that. Now this is the point when, okay, we throw it up, we said that it is slowing down, and at this point, at this time, it will just stop. Now after this time, what will happen? It still has an acceleration. Its speed is 0, its velocity is 0. It will speed up downwards. So it went up, it will stop over here, and then it will start speeding downward. Throughout this process, it is always accelerating downwards. It is first slowing down, but accelerating downwards. Then it is speeding up downwards, it's accelerating downwards. The acceleration, the object is always accelerating downwards. Is this point clear? The acceleration is always constant, and it is always in the downward direction. That is fixed, it doesn't change. Whether the object is speeding up or slowing down, it doesn't matter. The acceleration is always the same, it is pointing downward. Now the next thing, what about the position, the height of this object? Let's just say z of t is, what is the position of this object as a function of time? We know the velocity, what about the position? Well, there are various things you can do to calculate the velocity. Okay, one thing we said that, okay, the velocity, the position is always the area between the velocity curve and the time axis. Now we know if we draw the velocity curve as a function of time, we first threw it upward. So initially the velocity was negative. And if you see this is nothing but a line with a positive slope. So we can calculate the area between this total area. What is this total area? No, I mean in the general case. Let's say this is our V0, this is V of t. So the area is equal to the change in the position the average velocity times delta t, let's say. Now for a linearly changing velocity, the average velocity is always the initial velocity plus the minus final velocity divided by 2. So this is equal to 1 over 2 v0 plus v of t. Delta t is t minus t0. And t0 we had chosen to be 0. So the delta z is 1 over 2 v0. Now we had already calculated v of t. It is just this expression with, here we have t, v0 plus g of t times t. So this is v0 of t plus 1 over 2 g times t squared. This is delta z. This is the change in the height. Of course, if you want to calculate the position at a given, we can only calculate the changes in the position. So if we want to find the absolute position, we also need to know what was the initial position of the object. So if we just denote it by z0, the position at time t will be z0 plus v0 of t plus 1 over 2 g times t squared. This is how the position changes as a function of time. Of course, this is valid only if the acceleration is constant. Now, any questions on this one? Now, this is one way of calculating it. Now, we had another expression for the position as a function of time, or the change in the position. Let's say we want to find delta z. We can write it as an integral. We know that v of t prime times dt prime is the change in the position within a time interval of this length starting from t prime. So if you have at t prime, this is the velocity at time t prime. So if you wait for a very short amount of time, dt prime, this will be the displacement in that time interval, whatever v of t prime is. Now, adding these things all up, which is nothing but the integral, will give us the total displacement. And we need to add this from some initial time up to some final time t. So this will be the displacement starting from time t0 up to time t. Now we know what v of t prime is. This is equal to, well, t0 is 0. We had already calculated v of t prime. That is v0 plus g of t prime dt prime. Okay, what is the integral of v0? It's just a constant. v0 times t. What is the integral of, well, g is just a constant, we can take it out of the integral. The integral of t prime over t prime, t squared over 2. So this is our delta z. Again, if you just add the initial position, z0 plus v0 of t plus 1 over 2 gt squared. Now let's find the maximum height. Now when we were studying the velocity, we already said that if it is going upward, it will first go upward, it will slow down, at some point it will stop, and then it will start speeding up in the other direction. The velocity will be negative after that point. And we had already calculated the time at which this happens. At this time, time is equal to minus v0 over g. It will stop. So that will be the maximum height that will be the time at which it reaches the maximum height. So let's put it over here. The height that it will reach, z of t1 minus z0 from the initial point. Maximum displacement from the initial point. This will be equal to v0. t1 is minus v0 over g plus 1 over 2 g minus v0 over g squared, and this is equal to minus 1 over 2 v0 squared over g. So what is the maximum height? Now velocity is not 0. So this is what we calculated. The z at when it reaches the maximum point minus the initial z0, z value. This difference is this one. So can we say that this is the height? Why not? Well, the height is the height that it reaches relative to the point of release, let's say. Is this true? This equality. What does this minus sign tell you? Well, when you say well, you say, although v0 can be negative, this is always a negative number. v0 squared is always positive. G is always positive, so this number is always positive, and with this minus sign, this number is always negative. So does does a height of minus 5 meters make sense? Now, height, you always take the absolute value. The height is 1 over v0 squared over 2g. But then why is this minus sign?
Because choose the downside direction positive.
So this minus sign just tells me that it is going upward. That is our negative axis. So this minus sign is correct but the height is the absolute value of this one. That's how we define the height. It's just this length. The length is always positive. So one critical thing that you should always do is how do you interpret in your results? I mean, don't skip that step. So this minus sign needs some interpretation, and that minus just basically tells us that it is going upward. This difference, z of t1, is above z0. That is what this minus sign tells me. It doesn't tell me that the height is negative. But this is also kind of interesting because you see, even if V0 is positive, that is, if we throw it downward, this difference is positive. So how come? So what does that mean? Now, if V0 is positive, this time will also be negative. So how do we interpret that one? What is this one? Why is the time negative? What does the negative time mean? Okay, the history of motion.
It reaches its maximum height before we throw it.
Well, you see, if V0 is positive, I'm just throwing it downward. So does it reach the maximum height at all?
It's the height that it would have had if I didn't throw it at its initial, like, if I let it go, if I let it free fall initially without applying any force. That would be height. That would be the height that would require the energy that we put in.
Okay, so you're saying that initially we should put it, if we put the at maximum height, it's falling down.
I'm basically saying that if we throw it here, it has an initial velocity or something, and if we give it a given height that we get from this formula, and we let it go and it falls, the height that we calculate from this formula would be that height that we need to let it go from.
Okay, rather than throwing downward, if we release it from some height mass, then it will pass through this point with the same velocity. Okay, somebody else?
I think it's imaginary. I mean, it's not real.
Well, if you say imaginary time, that is a completely different thing. So that's not what you mean. Now, by the way, we do use imaginary time in certain branches of physics. It has a different interpretation. So you see, the main problem is, although we are using mathematics, well, mathematics doesn't know about the physics. So that's one of the reasons why we have to interpret our results. So if you, for example, just throw an object, it will go upward, it will go up, and then come downward. So this will be the trajectory. Now, it was completely up to us how to choose the time t equal to 0, t0, or t equal to 0. So in the previous example, when we were throwing it upward, so we just said, okay, at this point, that is our t is equal to 0 time, then the velocity is v0. But we could just as well choose this time as t equal to 0, and the velocity, it's just moving downward. We are just free to make the choice. And the mathematics only cares about what is your t equal to 0 and what is your velocity at that time. So if you just imagine an object that goes up and down with these values over here, or if you just take that object and throw it down at this point over here, the mathematics doesn't care about that distinction. So it will give you the result. The physics is the same at this time, after that t equal to 0, but the history might be completely different. We only know what happens afterwards. Now, in the other case, you see, if this is the thing this is the t equal to 0 that we choose, and if it comes from, at least the history of the particle, it was first thrown upwards, it reached the maximum height and then came down, the time it reaches the maximum height will be negative. That is because that's only because we are choosing a time after it reaches its maximum height as our t equal to 0. So anything that happened before it is a negative time. That's valid. And this maximum height, well, in this example at least, we can still define the maximum height. The maximum height is still this number. It still exists, it's a positive number. Of course, assuming that the object at this point, at this region, comes from an object that we had thrown upwards initially. In that case, there will be this maximum height. It will be an actual maximum height. Otherwise, if you are just throwing it downward, of course there is no maximum height. It wasn't making a motion with constant acceleration at t less than 0. So that's what I mean. You need to interpret the physics. Mathematics doesn't care about it. Any questions? Okay, let's give a 10-minute break.